Assalamualaikum. Today we are going to do October-November 2024, paper 3-2. Code is 9709. Alright, this is a pretty long paper. In our question number 1, expand 9 minus 3x whole power 1 over 2 in ascending powers of x up to and including the terms in x square, simplifying the coefficients. Okay, we will use the formula. Let me write that. A plus b whole power n. And if I open it, because he says including the term in x square, so I will open just 4 terms. In general form, first I will write a power n plus nc1 a power n minus 1 b power 1 plus nc2 a power n minus 2 b power 2 plus nc3 a power n minus 3 b power 3 plus dot dot dot. Now we must be very careful in placing the values. Our a is 9 and our b is minus 3x. So 9 power n is 1 over 2 plus nc1 1 over 2 c1 dot means multiply 9 power 1 over 2 minus 1 times minus 3x power 1 plus nc2 means 1 over 2 c2 multiply 9 power, this is our b, this is our a, 1 over 2 minus 2 times negative 3 x power 2. So I will stop here because the question says including the term in x square. So I got x square here. No need to write the next term. So now I'm going to simplify this. This is 9 power 1 over 2 is 3. And my 1 over 2 c1. Okay, let me try to explain you this. NCR equals n factorial over n minus r factorial times r factorial. So my 1 over 2 c1 equals n is 1 over 2 factorial over 1 over 2 minus 1 factorial times 1 factorial. Okay, the factorial of 1 over 2 is, you write, let me show you how you write n factorial. N factorial means n times n minus 1, n minus 2, n minus 3, and so on like this. You have to subtract one from each n. Suppose if your n is 5, so 5 factorial means, like, let me write in this way. 5 factorial means 5 times 1 minus from 5 is 4, 1 minus from 4 is 3, 2, and 1. You end up to 1. So 1 over 2 factorial, this will go like this. 1 over 2 times 1 minus from 1 over 2 minus 1 over 2, then 1 again minus from minus 1 over 2 minus 3 over 2, like that. So you stop it till here because your denominator is not a very big value. So 1 over 2 minus 1 means minus 1 over 2, and its factorial is minus 3 over 2 into factorial of 1 is 1. So you cancel the same values, like this will be gone, and you are left with 1 by 2. So your 1 over 2 C1, the answer is 1 by 2. So you can write it here, plus 1 over 2. And 9 power 1 over 2 minus 1. So 1 over 2 minus 1 is minus 1 over 2. And minus 1 over 2 means you bring the numerator to denominator, so the negative sign would be changed into positive sign. So you write it 1 over 2 times 1 over 3 times negative 3x plus, now you can work with 1 over 2 C2. So let me erase this so that we should have enough space. So 1 over 2 C2. So this is 1 over 2 factorial over 1 over 2 minus 2 factorial into 2 factorial. I'm following the same formula, NCR equals n factorial over n minus r factorial times r factorial. So our n is 1 over 2, our r is 2. So when you simplify this, one factorial of 1 over 2 is 1 over 2 times, you subtract 1 from 1 over 2, you get minus 1 over 2. You subtract 1 from minus 1 over 2, you get minus 3 over 2. Subtract 1 more from minus 3 over 2, so minus 5 by 2. Stop here, and over 1 over 2 minus 2 is minus 3 by 2, and its factorial is, you subtract 1 from minus 3 over 2, you get minus 5 by 2, times the factorial of 2 is 2 into 1, which is 2. So these two values will be cancelled, and you are left with minus 1 over 4 divided by 2. So minus 1 over 4 divided by 2, this gives you minus 1 over 8. So you write here minus 1 over 8. Minus 1 over 8. And 9 power 1 over 2 minus 2, when you simplify this, you get 1 over 27 times negative 3x whole square is, the square of negative is positive, so don't write it, and the square of 3 is 9, and x square plus dot dot dot. Further simplify this, so you get 3 minus 1 over 2x minus 1 over 24 x squared plus dot dot dot, and this is your answer. One must be very careful in handling this type of questions, because if you have any mathematical slip means the when you miss or you write the wrong sign, so your whole question will be wrong. Okay, by sketching a suitable pair of graphs, show that the equation cot 2x is equal to secant x has exactly one root in the interval 0 to pi by 2. Okay, cot 2x is, let me write this here with the different color. This is actually 1 over tan of x. And secant is 1 over cos. Okay, we have to sketch this, so we can sketch tan of x and we can sketch cos of x, but this is actually 1 over tan, so we can reciprocate it. And the tan of, okay, wait, let me correct it. This is not actually only tan of x, this is tan of 2x, because it's cot of 2x written there. Tan of 2x. So first of all, let me divide, because the interval said pi from 0 to pi by 2, and this is cot of 2x, which meant tan of 2x. So 2 means we have to divide 360 degree by 2. 360 means 2 pi. We are using radian here. So 2 pi divided by 2 means our interval will end up to pi. But we will look the sketch from 0 to pi by 2. Pi by 2 is 90 degree. So you also divide 90 by 2 means pi by 2 divided by 2. So this gives you pi by 4. So 0, pi by 4, then 90. 90 is our pi by 2. Then stop here. We make 1 and minus 1. And actually our asymptote will come here. And if I draw the normal tan, I start drawing it, so I will draw it like this. But this is, okay, we can also say this tan of 2x, because it's a sketch, so we cannot exactly show the gradient. So maybe tan of 2x comes like this, so we cannot show it properly because it's a sketch. So examiner will accept this. So if this is a tan of 2x, so how 1 over tan of 2x would be? So you draw in this you just reciprocate it. So this is your reciprocation. So you can erase this first. And cos of x comes like the wait. Cos of x comes like this. At 0 cos is 1, 90 cos is 0, and at 180 it is. So it comes something like this, but we have to draw from here. So this is our, this portion is our cos of x. So the reverse of this means reciprocal, because we have to draw 1 over cos of x, so we have to draw in this way. The cos of x will go like this. So you can erase this. So actually this is your sketch which examiner wants from you in this part. So it they are intersecting at one point only. I am circling it in the green color. So your answer would be, show that the equation this has exactly one root in the interval. So you have shown this, and you can write only one root. You can circle it as I circled it in green color. B part. Show that if a sequence of real values given by the iterative formula this converges, then it converges to root in part A. So we can remove the subscripts, the n plus 1 and n, these are known as subscripts. So we can remove the subscript and write the equation in term of x. X is equal to 1 over 2 tan inverse of cos of x. So you multiply 2 by x, so this becomes tan inverse of cos of x, and then I can write tan of 2x. When cos inverse comes here, it becomes tan. This is cos of x. Now take reciprocal. So I can write 1 over tan of 2x on both sides equals 1 over cos of x. So 1 over tan of x is cot of 2x, and 1 over cos is secant x. So I can write now shown. This part was of 1 mark only. Question number 3. Square roots of 6 minus 8i can be expressed in the Cartesian form x plus iy, where x and y are real and exact. By first forming a quadratic equation in x or y, find the square roots of 6 minus 8 in exact Cartesian form. Okay, so I can start by letting 6 minus 8i, the square root, equals x plus iy. Now square root both sides. So I can write 6 minus 8i square root equals x plus iy. I'm squaring both sides just to remove the square root. So I can get 6 minus 8i equals x plus iy whole square. Now open this, so it becomes x square plus 2xy I plus I squared y squared. So this further becomes 6 minus 8i equals x squared plus 2xyi minus y squared, because as we know I square equals -1. So 6 minus 8i is equal to, you collect x square and y square together, because these are the real part, and separate the imaginary part from it, so it becomes 2xyi. So now compare the real parts with the real and the imaginary parts with the imaginary numbers. So can I write x squared minus y squared is equal to 6, and this is my first equation. These are the real part, and I can compare 2xy equals minus 8. These are the imaginary part. So from here I can make y the subject. I can write y equals minus 8 over 2x, which is further if simplified I can get minus 4 over x. This is my second equation. Now substitute equation 2 into 1. So x squared minus, in y square I am going to write the value -4 over x whole square. Is equal to 6. Now we can further work on this, simplify it, so it becomes x squared minus 16 over x squared is equal to 6. Take the LCM, so you get x power 4 minus 16 is equal to 6x squared. Now bring all the values at one side. So x power 4 minus 6x squared minus 16 is equal to 0. Now make it a quadratic equation, so let x squared is equal to p. So I can write p squared minus 6p minus 16 equals 0. Factorize it, you will get the factors p plus 2 times p minus 8 equals 0. So one your p is equal to -2 and the other your p is equal to 8. So I can bring back x squared in p. So I can write x squared is equal to -2. So don't consider this side. Now work with this. So x squared is equal to 8, which gives me x is equal to square root of 8, and square root of 8 is 2 root 2 plus minus. You write plus minus 2 root 2. Now from equation 2, we can also find the value of y. So y is equal to minus 4 over x. So y is equal to minus 4 over, first you place a positive 2 root 2 and you get negative, this is 2 times root 2 over root 2. Now rationalize it. 2 negative 2 over root 2, when you rationalize it, you multiply it by root 2 divided by root 2. So you multiply this minus 2 with root 2, you get minus 2 root 2, and you multiply root 2 times root 2, which is 2, and cancel this. So finally you get negative. This is your y value, negative root 2. And again write y is equal to negative 4 over x. Now place negative 4 in x, you write minus 2 root 2. So negative sign cancel each other out, and 2 times 2 is 4, so you get 2 over root 2, which when rationalized you can write positive square root. So your 6 minus 8i square root, this is equals to 2 root 2 minus root 2i. This is your x part, and your negative 2 root 2 plus 2 root I. Now come to question number 4. Solve the equation 5 power x is equal to 5 power x plus 2 minus 10. Give your answer correct to 3 dp. So 5 power x is equal to, can I write 5 power x times 5 power 2, the same, the rule of indices, minus 10. Now let 5 power x equals a. So write it in the form of a now. A equals 25a. 5 power 2 is 25 and 5 power x is a, minus 10. So 25a minus a equals 10. So 24a equals 10. So a equals 10 by 24. So a equals 5 by 12. Now write 5 power x equals 5 over 12. Take LG on both sides. When you take LG on both sides, you write like this. LG 5 power x is equal to LG 5 over 12. So this gives you LG 5 power x is equal to minus 0.38. Now bring x on the side. So x LG 5 equals negative 0.38. So x equals negative 0.38 divided by LG5. And this gives us a value minus 0.54. Alright, this was question number 4. Question number 5. The complex number u is given by this. Find the exact value of argument. Complex numbers can be written in two forms, polar form or Cartesian form. The Cartesian form we write it like, suppose z equals a plus bi, and the polar form we write it z equals r cos theta plus I sin theta. R is the modulus. And you can write like this, z modulus. And theta is the argument. We write argument like arg. Provided there is a positive sign between cos theta and I sin theta. In our question, denominator has a negative sign, so we will change it into positive. And how we will change it into positive? Let me show you. U equals cos 1 over 7 pi plus I sine 1 over 7 pi over, I will multiply both with negatives, cos minus 1 over 7 pi plus I sine negative 1 over 7 pi. So from numerator, my argument cos 1 over 7 pi plus I sine 1 over 7 pi as theta is our argument, so my argument would be one over 7 pi. And from the denominator, my argument would be minus 1 over 7 pi. Okay, in part B, wait, let me complete this. Because it was division, so as we know that argument u1 over u2 is same if I write argument u1 minus argument u2. So I can write argument u 4 times 1 over 7 we have power 4 in the numerator, so we multiply it by 4. So 4 times 1 over 7 pi minus 1 over 7 pi, and this gives us 5 times 1 over 7 pi. So our argument u is equal to 5 over 7 pi. This is our answer. Now let's go to part B. Complex number u and u star are plotted on an Argand diagram. Describe single geometrical transformation that maps u onto u star and say the exact value of argument u star. The single transformation is a reflection of u onto u star in the x-axis, or we should call it in the real axis, because u star is a conjugate of u. You find the complex conjugate simply by changing the sign of the imaginary part. For example, to find the conjugate of 3 plus 4i, the conjugate would be simply conjugate. Let me write it clearly. Conjugate would be 3 minus 4i. So suppose if I sketch x plus iy, so this is x plus iy. Real and imaginary line. So its conjugate would be exactly the reflection in the real line, x minus iy. So thus argument u star equals minus 5 over 7 pi, as argument of u is positive 5 over 7 pi. Okay, question number 6. The variables x and y satisfy the equation ay equals b power x, where a and b are constants. The graph of L and y against x is a straight line passing through the points this and this as shown in the diagram. Find the values of a and b. Give each value correct to 1SF. So we write ay equals b power x. Take ln on both sides. Now, because ay are multiplying, so the rule of log says when you have a multiplication with log, you add them like in this way, ln a plus ln y. This is, you bring down the power on side, x ln b. This is, now make ln y the subject. You write x ln b minus ln a. This is your first equation. This is actually in the form of y equals mx plus c. Now you have coordinates given 0.50, comma 2.24. So your x is x and your y is not y. Actually, this is no ln y. So you write in ln you write 2.24 equals, you write 0.5 in x ln b and minus ln a. This is your equation number 2. Now the second coordinates are also given 3.40, 8.27. So this is your x and this is your ln y. So you write 8.27 in y, ln y equals 3.40 in x ln b minus ln a. So this is your second equation. Solve 1 and 2 simultaneously. So you write, let me write it for you again. 0.50 ln b minus ln a. This is first and this is second equation. 8.27 equals 3.40 ln b minus ln a. Now solve them simultaneously. You have to reverse the sign. This is positive, now becomes negative, this becomes positive. So minus ln a plus ln a will cancel each other out. So you get negative 6.03 equals negative 2.9 ln b. Negative and negative gone. So your ln b equals 6.03 divided by 2.90. This gives you 2.079. Now your ln b is 2.079. From here b equals, when ln goes on the other side, it becomes e, and 2.07 becomes a power of e. So you write b equals e power 2.079. So this is 7.99, which is approximately 8 up to 1 significant figure. This is your answer. Okay, for A, you again place the values in the equation. 2.24 equals 0.50 ln b. Actually, ln b, the value we have just found out, so let me write it again. And that is 2.079 2.079 minus ln a. Now from here you can find out the value of a. So ln a becomes 0.50 times 2.079 minus 0.24. So ln a equals minus 1.2003. So A equals e power minus 1.2003, which is approximately equals to 0.3. Question number 7, part A. Show that the equation this may be expressed as this, and tan x is not equal to 0. Okay? Tan power 3x plus 2 tan of 2x minus tan of x equals 0. So I can write tan of 3x plus 2. In tan of 2x, I'm replacing it with its identity, which is 2 tan of x over 1 minus tan square x. I have just used the identity of tan of 2x minus tan of x equals 0. Now 1 minus tan square x will multiply by, okay, first I multiply 2 with the bracket, so it becomes tan of 3x plus 4 tan of x over 1 minus tan square x minus tan of x is equal to 0. Your LCM is 1 minus tan square x, and that will multiply with tan of 3x. 1 minus tan square x is your LCM, plus 4 tan of x minus tan of x times 1 minus tan square x, and this is equal to 0. So in the new denominator will become 0 when it will multiply by 0. So your numerator is tan cube x minus tan power 5x plus 4 tan x minus tan x plus tan cube x is equal to 0. Further, when you simplify this becomes 2 tan cube x minus tan power 5 x plus 3 tan of x is equal to 0. Tan of x common, so tan of x is equal to 0, where tan of x is not is equal to 0 in the question. So leave it. Other factor is 2 tan square x minus tan of 4x plus 3 is equal to 0. So straight it up according to the power of the polynomial. So minus tan 4x plus 2 tan square x plus 3 equals 0. You multiply throughout by negative sign, so it becomes positive tan power 4x. Wait. Minus 2 tan of square x minus 3 equals 0. So this has been shown. You can write shown here. In B part, hence solve the equation this for 0 to pi, theta is between 0 and pi. Give your answer in the exact form. Exact form means we have not to use a calculator. So from part A, tan 3x plus 2 tan of 2x minus tan of x is equal to 0. This was tan 4x minus 2 tan square x minus 3 is equal to 0. Compare with, no, let me write it here. Compare with tan cube 2 theta plus 2 tan 4 theta minus tan 2 theta is equal to 0. After comparing this, can I say that my x here, my x can be equals to 2 theta? Now we can write tan 4 2 theta minus 2 tan square 2 theta minus 3 equals 0. Now let my tan square 2 theta equals y. I'm naming it. So I can write it in the form of y. So sorry. It becomes, y square minus 2y minus 3 equals 0. Now this is my quadratic form. Factorize it by using the midterm breaking. You will get the factors y plus 1 and y minus 3 equals 0. So one my y equals negative 1 and other my y equals 3. So tan square 2 theta is equal to negative 1. So there is no solution. No solution for this part. And replace y by tan square. Tan square 2 theta is equal to 3. So tan of 2 theta equals plus minus root 3. We have to stay between 0 and pi. So theta is less than pi and greater than 0. If I multiply theta by 2, I have to multiply both sides by 2 then. So my limits become from 0 to 2 pi. Now my basic angle for theta is tan inverse of root 3. So my basic angle is pi by 3. Now actually, if you see, because we had plus minus, so we have to see ASTC. My tan is positive here, my tan is positive, negative here, my tan is positive here in the third, and my tan is negative in the fourth. So I have to use all the 4 quadrants. And my basic angle pi by 3 is always made with the x-axis. So pi by 3 here, pi by 3 here, pi by 3, and pi by 3. So my first angle would be directly pi by 3, and I will use it with 2 theta because my tan is not only theta, my tan is 2 theta. So I will use 2 theta is equal to first my basic angle pi by 3, then by this angle is actually 180 minus pi by 3, and 180 is pi, so I will use pi minus pi by 3, which is 2 pi by 3. Then comes my third angle, this one, which is 180 plus pi by 3, and 180 means pi plus pi by 3. This is 4 pi by 3. And finally, I will check this theta, which is 360 minus pi by 3, and we say 360 as 2 pi. So 2 pi minus pi by 3 gives me 5 pi by 3. Now I will solve, let me write it separately clearly. So 2 theta is equal to pi by 3, 2 pi by 3, 4 pi by 3, 5 pi by 3. Now I will solve all this with 2. My theta is 1 by 1. Theta equals pi by 3 into 2. So it becomes pi by 6. Two theta is equal to 2 pi by 3. So my theta would be pi by 3. 2 theta is equal to 4 pi by 3. My theta would be equals to 2 pi by 3. 2 theta is equal to 5 pi by 3. My theta would be equals to 5 pi by 6. So these are my thetas and final answer. Question number 8. Parametric equation of the curve are this, and show that dy by dx is equal to minus 1 over 2 cos cube 2t. So first take x is equal to tan square 2t. So I can write x is equal to tan of 2t whole square. The same thing. Now I've differentiated dx over dt. This is 2 tan 2t into, now tan of differentiation of tan of 2t is secant square 2t, and the differentiation of 2t is 2. So multiply in the series, in the sequence. So you get 4, 2 times 2 is 4, tan 2t secant square 2t. This is your dx over dt. Now work with y is equal to cos of 2t. So dy by dt is equal to the differentiation of cos of t is negative sine of t. So write negative sine of 2t into differentiation of 2t is 2. So your dy over dt is minus 2 sine of 2t. Now write down the formula. Chain rule, dy by dt equals dy by dx into dx over dt. By dy by dx is equal to dy by dt into dt over dx. So my dy by dx equals dy by dt is minus 2 sine of 2t into my dt or dx is 1 over 4 tan of 2t secant square 2t. Actually, I did not have dt over dx. I had dx over dt. So to make dx over dt, I have to take its reciprocation. So I reciprocated, and now I will simplify these values. 2 times 2 is 4, and it becomes dy over dx becomes minus sine of 2t over 2 tan of 2t secant square 2t. You can take minus 1 over 2 on the side. Now you can write sine of 2t over, now use the identities in place of tan and secant. So you write sine of 2t over cos of 2t times secant is 1 over cos of cos square 2t. Now minus 1 over 2 sine of 2t over sine of 2t over cos cube 2t. Further, actually these two signs would be cancel each other out, and you can write minus 1 over 2 cos cube 2t. This is your dy by dx. In B part, hence find the equation of normal to the curve at point where t is equal to pi by 8. Give your answer in the form y equals mx plus c. So our dy by dx was minus 1 over 2 cos cube 2t. So take t is equal to pi by 8. So minus 1 over 2. I can write cos of 2t whole cube, and this gives me minus 1 over 2 cos of 2 times pi by 8 whole cube. This gives me minus 1 over 2 cos pi by 4 whole cube. And now you can use your calculator. It will give you dy by dx equals minus root 2 over 8. This is our gradient of tangent. So gradient of normal, m of normal, would be the reciprocal with opposite sign of gradient of tangent on the curve. So 4 root 2. How it becomes 4 root 2? If I show you your root 2 over 8 is the same as 8 over root 2. So rationalize it. So 8 root 2 over root 2 into root 2 is 2. So you get 4 root 2. So this is the gradient of your normal. Now at when t equals pi by 8, your x is equal to tan square 2t. Your x is equal to tan square 2 into pi by 8. This is tan square pi by 4, which is equals to 1. And in y is equal to cos of 2t, your y is equal to cos of 2 into pi by 8. This is cos pi by 4, and this gives you root 2 over 2. So your point would be 1 comma root 2 over 2. Now equation of normal, so use y minus y1 equals m into x minus x1. So y minus root 2 over 2 equals m is 4 root 2, x minus 1. So y minus root 2 over 2 equals 4 root 2 x minus 4 root 2. So your y is equal to 4 root 2 x minus 4 root 2 plus root 2 over 2. So y equals 4 root 2 x minus 8 root 2 plus root 2 over 2. So y is equal to 4 root 2x minus 7 root 2 over 2. This is your final answer. Question number 9. With respect to origin, O, the points A, B, and C have position vectors given by OA, OB, this. Point D such that ABCD is a trapezium with DC 3 times AP. Find the position vector of D. So he said DC is equal to 3 times AP. So DC means, because the position vector, I can write OC minus OD. 3 times AB means OB minus OA. So write down the values: minus 3, minus 2, 2. OD I have to calculate, find out. So 3 times OB is 0, 4, 1. OA is 2, 1, negative 3. Further, after simplification, I get minus 3 minus 2, 2 minus OD equals 3 times minus 2, 3, 4. This gives me minus 3 minus 2, 2 equal, minus OD equals 6, 9, 12. So from here, OD equals minus 3 minus 2, 2 minus 6. This is actually minus 6, 9 and 12. So OD equals 3 minus 11 minus 10. This is your OD. B part is the diagonals of trapezium intersect at point P. Find the position vector of P. So he told us DC equals 3 times AB. It means that if I draw a sketch, this is my AB and this is my DC, 3 times bigger than AB. And here are my diagonals. Here is my P. So let's find the vector equation of AC and BD. Vector equations of AC and BD. So first find the direction vector of AC. To find the direction vector of AC, I have to write OC minus OA. So my AC is, OC is my minus 3, minus 2, 2. OA is 2, 1, minus 3. Simplify it, you get minus 5, minus 3, and positive 5. This is my direction vector for AC. So my equation, vector equation, set R1. R1 equals A plus lambda times M. M is your direction vector. A is your fixed point, OA. So I can write R1 equals my A is my fixed point OA, so column vector of OA is 2, 1, minus 3 plus lambda times my direction vector which I just found out, minus 3, minus 5, minus 3, positive 5. So now you can name it equation 1. Now work with for BD, do the same thing as you did for AC. So BD equals OD minus OB, and my OD is 3 minus 11 minus 10. My OB is 0, 4, 1. Simplify it, you get 3 minus 15 minus 11. So this is my direction vector for BD. Now line BD, make it R2. My fixed point B plus mu times M. My B is my OB. So if I use values in it, my OB is column vector is 4041 plus mu times direction vector, my 3 minus 15 negative 11. This is my equation number 2. To find the intersection point, equate 1 and 2, means R1 equals R2. So my R1 is 2, 1 minus 3 plus lambda times minus 5 minus 3, 5 is equal to, my R2 is 0, 4, 1 plus mu times 3 minus 15 minus 11. So I can write 2 minus 5 lambda, 1 minus 3 lambda, minus 3 plus 5 lambda. This is equals to 3 mu, 4 minus 15 mu, and 1 minus 11 mu. Name them equation number 3, equation number 4, equation number 5. Now use equation 3 and 5 equation 3 and 5 because they have lambda with opposite signs. So two minus 5 lambda is equal to 3 mu, and minus 3 plus 5 lambda is equal to 1 minus 11 mu. So minus 5 lambda and plus 5 lambda gone. So you got minus 3 plus 2 is minus 1 equals 1 minus 8 mu. From here your mu is equal to 1 over 4. Equation number 2, R2 equals 0, 4, 1 plus mu times 3 minus 15 minus 11. So you R2 equals 0, 4, 1 plus, put the value of mu 1 over 4, 3 minus 15 minus 11. So you multiply 1 over 4 inside. So your R2 is 0, 4, 1 plus 3 over 4 minus 15 over 4 and minus 11 over 4. Finally, you get R2 equals 3 over 4, 1 over 4 and minus 7 over 4. Or this is your actually position vector of OP. You can also write it in this form, 3 over 4i plus 1 over 4j minus 7 over 4k. Using a scalar product, calculate angle ABC. So BA dot means multiply, BC equals magnitude of BA into magnitude of BC cos of theta. So this is actually, suppose if I draw a line and I write ABC here, so this is the angle. So these are the vectors, so BA times BC, and this is your angle theta. Your BA is OA minus OB. 2, 1 minus 3 minus 0, 4, 1. This is 2 minus 3 minus 4. This is your BA. And likewise, find out BC also. So it is OC minus OB. OC is minus 3 minus 2, 2. And OB is 0, 4, 1. This gives us minus 3, minus 6, and 1. So write down these values here in the formula. So your BA is 2 minus 3 minus 4 times your BC is minus 3 minus 6 and 1 equals magnitude of BA. So magnitude of BA 2 square plus minus 3 square plus minus 4 square whole under root. So this is square root of 29. And same magnitude of BC is minus 3 square plus minus 6 square plus 1 square whole under root. So this is square root of 46. So write these values here, square root of 29 times square root of 46 cos of theta. Now multiply the first 2 into minus 3, 2 into minus 3 plus minus 3 into minus 6 plus minus 4 into 1 equals root 29 times root 46 cos of theta. Now simplified cos of theta would be equals to 8 over root 29 times root 46. So theta is equal to cos inverse of 8 over root 29 times root 46. So theta is 77.3 degrees. Question number 10. A balloon in the shape of a sphere has volume V and radius R. Air is pumped into the balloon at a constant rate of 40 pi starting when time t is equal to 0 and r is equal to 0. At the same time, air begins to flow out of the balloon at a rate of 0.8 pi r. The balloon remains a sphere at all times. Show that r and t satisfy this. Interesting question. Okay, dv over dt means differentiation for inflow equals 40 pi. Given actually this is rate. dv over dt for outflow, this is also given 0.8 pi r. When air started to pump in, at the same time air started to flow out. So I can take the difference of these two, dv over dt equals 40 pi minus 0.8 pi r. Volume of sphere to be used here because question says that a balloon remains a sphere at all times. So V equals 4 over 3 pi r cube. So take its differentiation. So dV over dr would be equals to, you bring down power and it will be cancelled with 3. So you are left with 4 pi r square. Now use the chain rule formula. dv over dt is equal to dv over dr times dr over dt. So make dr over dt your subject. So it becomes dv over dt times dr over dv. So 40 pi minus 0.8 pi r times reciprocal of this, because we have we don't 1 over 4 pi dv over dr. So dv over dt. So what we had given, dv over dt was given and the difference was dv over dt. Okay, 40 pi minus 0.8 pi r dr over dt over dv over dr is there. So we have to take its reciprocal, 1 over 4 pi r square. Now we can change the 0.8 into fractions. So 40 pi minus 4 over 5 pi r times 1 over 4 pi r square. So now you can take out 1 over 4 pi r square times 40 pi minus 4 over 5 pi r. Now come here, see working, the rest of the working is here in this part. Take 4 pi common. So 4 pi over 4 pi r square so 10 minus r over 5. So 4 pi is gone. So 1 over r square times 50 minus r over 5. So this gives us 50 minus r over 5r square. And this has been shown. In B part, find the quotient and remainder when 5r square is divided by 50 minus r. So 5r square divided by 50 minus r. So you write 50 minus r, like minus r plus 50 you can also write. And now you have to bring 5r square from minus r. So I multiply minus 5r with it, so I get positive 5r square. Now minus plus minus 250r. So I can write minus 5r, and in the here under it 5r square minus 250r. Change the sign, this gone, so 250r is minus r plus 50. Now I have to bring 250r, so I have to multiply minus r by minus 250 only. So it will be 250r minus 12,500. So my minus 250 right here, and write down 250R minus 12,500 minus plus cancel, so your remainder is this. Now you can write quotient minus 5R minus 250 and remainder 500. Part C. Solve the differential equation in part A, obtaining an expression for t in terms of r. So dr over dt equals 50 minus r over 5r square. So cross multiply to bring the like terms with each other, like 5r square over 50 minus r is equal to dt. Now integrate both sides. So integral of 5r square over 50 minus r equals integral of dt. So integral of minus 5r minus 250 plus 12,500 over 50 minus r is equal to integral of dt. Actually, I just wrote it this portion like, suppose if we divide 4 by 3, so we write 1 whole 1 over 3. Here in algebra we write 1 plus 1 over 3. So in the previous part, our quotient was minus 5r minus 250 and our remainder was this, so I can write minus 5r minus 250 plus the remainder 12,500 over the divisor 50 minus r. So this thing I have written here. Now integrate it. So minus 5r square over 2 minus 250r minus 12,500 ln 50 minus r modulus is equal to integration of dt is t plus c. Now t equals 0, r equals 0. When you put t 0 and r 0, you will get c equals minus 12,500 ln 50. Now you can put back this value of c in the equation integrated portion. So you write minus 5r square over 2 minus 250r minus 12,500 ln 50 minus r equals t minus, in place of c, you can write its value 12,500 ln 50. Now from here t equals minus 5r square over 2 minus 250r minus 12500 ln 50 minus r plus 12500 ln 50 . So t equals minus 5r square over 2 minus 250r plus 12500. This ln 50 minus r plus ln 50, because their coefficients are same, so they are adding, so we can divide it. Actually, if you write vice versa, first you write 12500 ln 50 minus 12500 ln 50 modulus, so you, because now they become minus, so you have to divide. So you can write 12500 ln 50 over 50 minus r. That's it for this part. In part D, find the value of t when the radius of the balloon is 12. So this is a simple 1 mark question. So t equals minus 5, 12 square over 2 minus 250 times 12 plus 12500 ln 50 over 50 minus 12. So t equals 70.46. T equals 70.5. Question 11. Let f of x equals 2 e power 2x over e power 2x minus 3 e power x plus 2. Part A, find f prime x. F prime x means differentiation, and hence find the exact coordinates of the stationary point of the curve with equation y is equal to f of x. So this is a fraction, so we will use quotient rule to differentiate this equation, and the quotient rule is f prime x equals u over v. If I say u to the numerator and v to the denominator, so the differentiation would be v as it is into derivative of d over d u, and minus u as it is into derivative of v whole over v squared. So let's do the differentiation. V as it is, so e power 2x minus 3 e power x plus 2 into derivative of u. So u is my numerator, so its derivation would be 2 e power 2x times 2 minus u, as it is, my u is 2 e power 2x times e power 2x times 2 minus actually we should write it without brackets. So this is u as it is into derivative of v. So derivative of v is e power 2x into 2 minus 3 e power x into 1 whole over v square. E power 2x minus 3 e power x plus 2 whole squared. So now our simplification starts. E power 2x minus 3 e power x plus 2 times 4 e power 2x minus 2 e power 2x times 2 e power 2x minus 3 e power x whole over e power 2x minus 3 e power x plus 2 whole squared. Now 4 e power 4x minus 12 e power 3x I'm multiplying 4 e power 2x with the bracket plus 8 e power 2x minus 4 e power 4x plus 6 e power 3x whole over e power 2x minus 3 e power x plus 2 whole squared. Now plus 4 e power 4x minus, they are cancelled. So the leftovers we are going to write minus 6 e power 3x plus 8 e power 2x whole over e power 2x minus 3 e power x plus 2 whole squared. And further, if I take 2 e power 2x as common, this is equal to 0. So in the next step, this denominator will multiply with 0 and will be vanished. So 2 e power 2x minus 3 e power x plus 4 equals 0. So 2 e power 2x is equal to 0 and minus 3 e power x plus 4 equals 0. From here, e power 2x would be equals to 0, and this is, take ln on both sides, ln e power 2x equal ln 0. So ln 0 gives you math error, so this is not valid. Now work with this one. So minus 3e power x is equal to minus 4 minus con. So 3e power x is equal to 4, and e power x is equal to 4 over 3. Now take ln on both sides. Ln e power x equals ln 4 over 3. So x is equal to ln 4 over 3 because ln equals ln is equal to 1 always. So this is our answer. In the B part, alright, this is one of our answers, and I don't have any more space left. So I have to find out y coordinates. So I can write y is equal to 2e power 2x over e power 2x minus 3e power x plus 2. So replace ln 4 over 3 in x. So 2e power 2 times ln 4 over 3 over e power 2 into ln 4 over 3 minus 3e power ln 4 over 3 plus 2. So this will give me we should know that e to the power ln cancel each other out. So let's first simplify this and we will cancel them. 2 e power ln 4 over 3 squared. This 2 will go up and it will become square over e power ln 4 over 3 squared minus 3 e power ln 4 over 3 plus 2. Now with the blue color I will cancel e and ln's. Ln and e go on here. E and ln will cancel each other out. E and ln will cancel each other out. Now let's write the left ones. Y equals 2 times 16 over 9. That 4 over 3 whole square is 16 over 9. 16 over 9 minus 4 plus 2. This gives us minus 16. So our stationary coordinates of our stationary point would be, our x is ln 4 over 3 and our y is minus 16. Now B part, integral from ln 3 to ln 5. we have to integrate f of x, and we have to take substitution u is equal to e power x. So our f of x is 2 e power 2x over e power 2x minus 3 e power x plus 2 dx. Now u equals e power x, so differentiate this first. So d over dx of u equals e power x times 1. So du over dx equals e power x. Now make du the subject here. So I can write du equals e power x dx. Now working with the substitution, ln 3 to ln 5. Can you write e power 2x as 2 e power x times e power x? Over, and e power 2x I can write e power x whole squared. It's the same thing. Minus 3 e power x plus 2 dx. This is my x is equals ln 3. My u is equal to e power x. When my x is ln 3, I'm actually working on the limits. My u is equal to e power x. So I can write u is equal to e power ln 3. So as we did in the previous working, ln and e cancel each other out. So I can write u is equal to 3. And my x is equal to ln 5. I have u is equal to e power x. And I can write u is equal to e power ln 5. Again, ln and e will be cancel each other out, and I can write u is equal to 5. My new limits are now integral 3 to 5. Now 2u over u square minus 3u plus 2 du. Now let's make factor of this. 3 to 5 2u over factors of u square minus 3u plus 2 would be u minus 2 times u minus 1 du. Now I have to do partial fractions. So 2u over u minus 2 u minus 1 equals a over u minus 2. plus b over u minus 1. Now 2u over u minus 2 u minus 1 equals, take LCM here, u minus 2 and u minus 1. So a will multiply with u minus 2 and b will multiply with u minus 2. So the denominator on both sides of is equal to signs are same, so you have just to write the numerator now. 2u equals a u minus 2 plus b u minus 2. To eliminate a or b, you have to use their values of u, equate them with 0. So if we take u minus 2 equals 0, we get u is equal to 2. So 2 into 2 equals a 2 minus 2 plus b 2 minus wait. U minus 2, u is equal to 2. Actually, this is, I have done some little mistake. This is, a is u minus 1. Here is u minus 1. By mistake, I have written that. So, u minus 1. Okay, now 4 equals a, and this will be gone. So a is equal to 4. And now take u minus 1 is equal to 0. So from here u equals 1. Now 2 into 1 equals a 1 minus 1 plus b 1 minus 2. So 2 equals, this will be 0. 1 minus 2 is minus 1. So minus b. So this gives us b is equal to minus 2. I'm going to use the additional page. So my partial fractions would be 2u over u minus 2 u minus 1 is equal to 4 over u minus 2 minus 2 over u minus 1. Now integrate limits 3 to 5, 4 over u minus 2 minus 2 over u minus 1 du. 4 is our constant value, so the denominator u minus 2 would be dealt like ln u minus 2, because the differentiation of u is 1 and we have 1 in the numerator if we take out 4 outside. So integration of 1 over u minus 2 would be ln u minus 2 minus take out 2 at side, and integration of 1 over u minus 1 would be ln u minus 1. Now put the limits from 3 to 5. Upper limit minus lower limit Now simplify all this. Four ln 3 minus 2 ln 4, 4 ln 1 minus 2 ln 2 okay, ln 1 is 0, so this part would be 0. Four ln 3 minus 2 ln 2 square minus 0 minus 2 ln 2. For ln 3 minus that 2 will come down, it makes it 4 ln 2, no need to write 0, minus 2 ln 2 so ln 3 power 4, this 4 becomes a power of 3 minus 4 ln 2 minus 2 ln 2, this is actually 2 ln 2. And these ln, I can further write this ln 3 power 4 minus ln 2 power 2. So when logs, there is this minus sign between logs, so we can divide it like this, ln 3 power 4 over ln, sorry, no, not ln here, we can just write ln 3 power 4 divide 2 power 2. So this is ln 81 over 4. This is our final answer. Thank you.